Perfect. Come again. Today we'll be solving a question related to convolution. And here is the question. Uh, an LTI system has impulse response h of t equals to u of t minus 1. If the input is x of t equals to u of t minus 2 and the output is y of t, then the value of y of 2 is, okay. So we need to find y of 2, means at 2 seconds we have to find what is the value of the output when the input is u of t minus 1 and the when the impulse response is u of t minus 1 and the input is u of t minus 2. So it can be done with using various ways. Now one way is to solve it through Laplace. One way is taking Laplace. Okay, how we can use Laplace? So, say this is our h of t, okay, which is our system. This is x of t and this is y of t. Okay, so what we can do is we can simply write it as y of t can be written as x of t, and when it is convolved with h of t. Okay, so if we take Laplace, then it is simply multiplication. So x of s dot h of s. Okay, so we can use the Laplace property, and with that we can solve this question. Okay, that is one way of doing it. The another way of doing this question is using the properties of convolution. So the properties of convolution, specifically the properties related to the unit step input. So what is that property? The property is that whenever you convolve a unit step with a unit step, you get a ramp input. Okay, so this unit step and this unit step, when they are convolved, you get a ramp like this. Okay, this is the ramp. Okay, so ramp is starting at 0, and again like at 1 the value will be 1 second, the value will be 1, at 2 the value will be 2. So this is how the ramp is going to look like, and this will be the input. Okay, I have shown the input here. This is the input, a simple unit step input. Now this is one property that we need to use, and the second property is when there is a delay. Okay, now same convolution is being done, but there is a delay of m and q units. Okay, so what is happening here? We are generating a ramp, but it has the combined delay. Okay, say m unit delay was there for the first unit step, and q unit delay was there for the second unit step. So we are combining it. Okay, so it is r of t of m minus q, r of t of t minus m minus q. Okay, so all that delay is going to be added up. Okay, so now let us proceed with this approach and let us see whether we can find an answer to the question or not. Okay, so you can see here now h of t is u of t minus 1. Okay, and x of t is u of t minus 2. So now again, so y of t, what is y of t? Now y of t is simply the convolution. Okay, so how we can write y of t? Y of t is equal to x of t, and it is convolved with h of t. Okay, so it will be written as u of t minus 1 convolution of u of t minus 2. Okay, so how we can write it? This is r of t minus c. This is minus 1 which will come here, and again this minus 2 will come here. So it is r of t minus 3. Okay, now you know that r of t was this function. Okay, it was starting from 0. So r of, okay, so r of t minus 3 will start from 3. Okay, so it will start from 3 here, see, and before that it is going to be 0. So you can simply write r of t minus 3 as t minus 3 u of t minus 3. So now you can see that it is 0 before 3. Okay, you can see that this part is 0, this is 0, this is, there is nothing here, and after that it is going as a ramp. Okay, so if I ask you r of 2, what is r of 2? Okay, so you can, or what is y of 2? Y of 2 is r of 2 okay, r of 2 minus 3, and this is going to be 0, so y of 2 is going to be 0. So this is one way of solving this question, okay, apart from the Laplace transform that we are taking. This is one another way where the property of convolution can be used to find what is the response of the system, okay. So the answer is y of 2 equals 0, okay. So thank you for watching this video.